Statistics is a branch of mathematics that we use to describe data. We do this in many different ways. We're going to learn about a couple of them in our class. We're going to learn about measures of central tendency, which is this week's topic. And next week, we'll be looking at measures of dispersion, or how far the values are dispersed around the mean value. That's an even more interesting topic, but we're getting ahead of ourselves there. So let's talk about measures of central tendency. We learned about three in this week's chapter, and we're going to work a couple problems. First of all, we learned about the mean, or the average. We also learned about the median, which is another very descriptive and very useful measure of the central tendency of a set of data. And we also learned about the mode, which I'm going to say is the least descriptive of the three. It has less usefulness. It's rare that we would choose the mode as being the best measure of central tendency, but as you will find out in your critical thinking assignment this week, there is a special case when it is very handy. Okay, let's do a problem. I've written one here. You can see it up in my Word window. We want to calculate the mean, the mode, and the median for the following set of data. All right, let's start with the mean. Mean, which we often abbreviate X bar, is equal to the sum of the values divided by the number of values. This symbol in the numerator looks like a big E, is a Greek symbol. It's the letter sigma, and it stands for the sum of. So the mean is the sum of the x's divided by n, the number of values. I've done some work beforehand, and I added these values up. There's some negative numbers in there. No big deal. There's even a 0 in there. No big deal. That's a number just as the same as any other number. But if you add those up, you will find that the sum is 43 and that there's 17 values. And when you push the buttons on your calculator, you derive a mean of 2.53. All right, well, that looks like a fine number, but is it the best? We're not sure. Let's calculate the median. Now, the median is the value that's in the middle. If you are to arrange your values from low to high and find the one that's in the center, that's the median. If there's an odd number of values, a single value in that list will be the median. If there's an even number, you're going to have to take the average of the two center values, and that will be the median. Now, in order to do the median, I want to make one strong recommendation that you don't try doing it by looking at a set of data like this, that instead you sort the data from smallest to largest. It's the only way to do it. Otherwise, believe me, you're going to make a mistake. Okay, I've done that. Median. And here are the values in sorted order. -8, -6, -3, 0, 2, 2, 2, 3, 3, 3, 3. And I'm going to jump down to the next row because I'm running out of space. 4, 6, 7, 7, 9, 9. Do we have 17 values? We better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yes, I got them all. Now we have 17 values. How do you find the one in the middle? Well, I suppose you could put your finger on them and start counting in from either end. I always do this. Let's see. We got 17 values. Half of that is going to be 8.5, which means I'm going to have... It's an odd number, so there is going to be a single number in this list that is the median. We're going to have 8, and then 1, then 8. And this guy here, this one in the middle, is going to be the median, right? 8 plus 1 plus 8 is 17. So I'm going to count in 8. 1, 2, 3, 4, 5, 6, 7, 8, which means that one corresponds to that one in the middle. There should be 8 on the other end. 1, 2, 3, 4, 5, 6, 7, 8. There are. Our median is 3. Very good. How do they compare for this data set? Well, we had a mean of 2.53. which, falls somewhere in here. And the median was 3. They're actually quite close together for this data set. So I would say for this data set that both the mean and the median are fine measures of central tendency. Okay, well, good enough. But let's change the problem a little bit now and see when things fall apart. There are many distributions that have what are called outliers, or values that kind of don't fit the rest of the values. I think your author used salaries as an example, and maybe the prices of houses as an example, where you might have houses for 100,000, 150,000, 140,000, 160,000, but you got a couple of those $1 million and $2 million houses in a list, and so that those values are going to skew things, and they're going to make the mean look a little bit odd. And in this case, when we do have those outliers, we often will report the median as the best measure of central tendency. And let's do that now. Let's add two values to this data set. Let's add minus 60 and minus 40 to our data set. And let's see how things look now. Okay, so now I want to calculate the mean, and it's going to be the sum of the x's over n. And let's see, we had 43, but now we have to add two more numbers, minus 60 and minus 40, and yeah, we can just do the math like that. We're still divided by 17. Oh, no, we're not. We've added two more values, and we now divide by 19. And 43 minus 60 minus 40 is a negative 57 over 19. I got really lucky on this one. That is negative 3. So look what's happened. Our mean has gone from 3. No, I'm sorry. That's our median. But our mean was 2.53, and our median was 3. But now our mean is way down to negative 3 when we add those two outliers into our data set. It skewed things, hasn't it? There's all these values to the right of negative 3 and only 4 values in our data set to the left of negative 3. I would say for this data set, since we've added outliers which skewed the data set, that the mean is no longer the best measure of central tendency. In this case, I would use the median. Let's calculate the median. I've taken a minute here and added some descriptive pieces. Here was our first median. Our mean was 2.53. Then we added the outliers, and our mean dropped down to negative 3. Call that our mean with outliers. And now we want to look at our new median. Okay, median, we got to find the middle value. So we had 17, and we did the 818 thing. Now we have 19. And so we're going to do 919, right? There's going to be 1 in the middle because it's odd, and they're going to have 9 on either side of it. So I'll count in 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's, I'll call the second median. It's the same number. It's moved over 1 slot, but you can tell that instead of letting these outliers sway the average to the left towards their end, the median did not let them do that. And the median, again, in this case, I'm saying is a better measure of the central tendency of this data set.